Hello, welcome back. Today we are going to be starting our brand new unit on the Pythagorean Theorem. So let's go ahead and get started. So our objective for today is I will be able to use the Pythagorean Theorem to find missing side values of a right triangle. So just as a side note, and I do want you to write this down, the Pythagorean Theorem only works with right triangles. It doesn't work with any other type of triangle, only works with the right triangle. And one way that we can tell 100% sure that it is a right triangle if we don't have the angle measurements written is this little square on the side of the triangle. Sometimes the right triangle doesn't always look exactly like this. Sometimes it's upside down, it's sideways, it's flipped. There's many different types of right triangles. They could be flipped all around. And although I only drew the side, the little box, half box in the corner of this one, these are all right triangles. So the Pythagorean Theorem. So when we're talking about the Pythagorean Theorem, we like to label the sides of the triangles with A, B, and C. So one side is A, the other side is B, and then lastly the third side is C. Now we have special words for these, and as you guys probably already know this, side A and side B are both legs. These could be interchangeable. This could be side A or this could be side A. It does not matter as long as A and B are both legs. Side C is always the side opposite of the right angle, and it is called the hypotenuse. We know that it's the hypotenuse because it's on the opposite side of the right angle, and it's always the longest side. It's really important to know these terms because you will be using these terms to understand the Pythagorean theorem and to solve application problems with the Pythagorean theorem. Right, so as we talked about in class, the Pythagorean theorem itself is a squared plus b squared equals c squared. This is something you need to memorize. You need to memorize this theorem because you will be using this all of the time. You will use this in so many things so far starting this year, and as you continue as mathematicians, you will use this all of the time. Alright, so let's take a look at our first problem with the Pythagorean theorem. So first we have this triangle that A is 3 and B is 4, but we don't know what C equals. So please write down the Pythagorean theorem again. It's really a good habit to get into as we solve these, to write down a squared plus b squared equals c squared every time, so then we can start to memorize this theorem. Alright, so we have the formula or the theorem a squared plus b squared equals c squared. So now simply we plug in the missing values to figure out the unknown. So a is equal to 3, so we have 3 squared plus b is equal to 4. 4 squared equals, and we don't know c, so we're going to keep that as c squared. Now we solve for the missing variable. So exponents first, 3 squared is 9. 4 squared is 16, and we just leave c squared by itself as it is. 9 plus 16 is 25, so we have 25 is equal to c squared. And as you recall earlier when we started solving equations with exponents, how to get rid of this squared, you simply do the opposite, or the square root. So the square root of 25 is 5, so 5 is equal to 5 is equal to c. So the side length of c is 5. Let's take a look at another one. So this one we have a is equal to 12, b is equal to 5, and c is equal to an unknown value. That's what we're trying to figure out. So please write down the theorem a squared plus b squared equals c squared. And now let's start plugging in. A squared is the same thing as 12 squared plus 5 squared, because b is equal to 5, is equal to c squared. 12 squared is 144. Plus 25, because 5 squared is 25, is equal to c squared. Okay, 144 plus 25 is equal to 169. Is equal to c squared. To undo or to get rid of the exponent, you have to do the square root. So c is equal to 13. Okay, so these are some special triangles. The previous one and this one are some special triangles. You see that they come out perfectly. They're whole numbers. There's the numbers that, you hear them 3, 4, 5 triangles and 5, 12, 13 triangles are special triangles that we come out equally as whole numbers. The next one that we're going to look at aren't going to be as pretty, but we can still definitely solve them just the same. So the next example, we have a is equal to 9, b is equal to 7, and we don't know the c value. So first write down the Pythagorean theorem again, a squared plus b squared equals c squared. We plug in the values just like we did before. 9 squared plus 7 squared is equal to c squared. 9 squared is 81 plus 7 squared is 49. We don't know what c squared is equal to yet. 81 plus 49 is 130 is equal to c squared. To undo the exponent, you need to do the square root of both sides. So c is equal to now 100. The square root of 130 is not a perfect square. So what we're going to do is we're going to just simply leave it as it is, the square root of 130. Now you could type this into your calculator and you could get an approximation, and some teachers like that, but I would prefer, as you're doing this with me, that you just keep it as the square root, because it's just a more precise way to say what the hypotenuse value is. Right, so another example is we won't always have to find c. Sometimes the missing value is a or b. So let's take a look at this. So once again, write down a squared plus b squared equals c squared. Okay, and plug in the numbers just like we did before. So a squared plus b is 10. 10 squared is equal to c is 15. 15 squared. A squared, we don't know what that value is. 10 squared is 100. Is equal to, and 15 squared is 125. Alright, so to get a all by itself, we need to subtract 100 from both sides. A squared, oops, I'm sorry, this is 225. I'm sorry about that. 225. So a squared is equal to 225 minus 100 is 125. To undo this, you have to do the square root of both sides. A is equal to the square root of 125. The square root of 125 is not a perfect square, so the side length a is the square root of 125. Alright, our next example, once again, we're trying to find the missing side length of b, or one of the legs. So write down the Pythagorean theorem, a squared plus b squared equals c squared. You fill in the missing values. A is 2, so 2 squared plus, we're trying to figure out b is equal to 8 squared. 2 squared is 4, plus b squared is equal to 8 squared is 64. Subtract 4 from both sides. B squared is equal to 60. To undo it, you need to square root both sides. B is equal to the square root of 60. Alright, so this is pretty straightforward, and I think that you guys are really going to get the hang of this, especially the more practice that we do. So the next thing that I need you to do is try this one on your own and bring me the answer into class tomorrow. We will be continuing to work on the Pythagorean theorem, how it works, and some practice when you come into class tomorrow. Alright, so thank you so much for actively listening and for taking great notes, and I will see you later in class. Oh, and please don't forget to write any questions down that you may have if something's confusing, or if you just need me to clarify anything. Alright, see you later. Have a great day.